Assalamu alaikum. I am Dr. Abdul WAHAB, Associate Professor, Department of Pharmacy, Quart University of Science and Technology. I am course instructor for the subject dispensing pharmacy, and our today topic is methods of preparation and extemporaneous dispensing of immersion, part 2. In our previous lecture, we have discussed all about the background of immersion. So today we are going to discuss about the different methods which are used for the preparation of emulsion and similarly extemporaneous dispensing of emulsion. So as you can see over here in discussion outlines, methods of emulsion preparation, different tests for identification of emulsion, because after the formulation or after the preparation extemporaneously emulsion, so we can use the different test for the identification of emulsion, that either this emulsion is water in oil or water in oil. So similarly emulsion stability, so after preparation we can check the instability of emulsion. So we will also try to discuss about the emulsion stability or emulsion instability. Similarly, we will also try to discuss about the extemporaneous dispensing of emulsions, the different extemporaneous mixtures of emulsion. So methods of emulsion preparation, you can see over here. On small scale, for extemporaneous preparation of emulsion, four methods are used. Like which are continental or dry gum method, English Arvadaga method, bottle or Forbes bottle method, and auxiliary method. So these are the four methods which are used for the extemporaneous preparation of emulsion, like continental or dry gum method. So for dry gum method we mostly use the term continental method. Similarly, for the English or wet gum method we can use the term English method. For the bottle, four bottle methods, and the last one is auxiliary method. Preparation of emulsion depends upon components and equipments. For small scale preparation we need dry, wedge, wood mortar and pestle. For small scale we mostly use mortar and pestle, hand homogenizers and mixer, etc. While for the large scale we need large mixing tanks. So in dry gum method, wet gum method, so these are the different methods which are used for the preparation of emulsion. So in this case, like in dry gum method, so the ratio of water, gum and oil should be like this: 4 parts of oil must be used and 2 parts of water and 1 part gum. So in dry gum methods, similarly in the case of wet gum method, the same ratio can be used, like 4 parts of oil, 2 parts of water and 1 part of gum. As you can see over here, continental or dry gum method, the first one, continental or dry gum method. Emulsifiers like acacia is mixed with oil before water addition. Why we use the term dry gum method? We use the term dry gum method for this method of preparation of emulsion, because in this case we add the emulsifier, mostly acacia, into oil before the addition of water. So therefore we use the term dry gum method, because in this case we add the acacia, the emulsifier, to the oil before the addition of water. The quantities of oil, water and gum for primary emulsion are calculated, like as we have discussed, that there must be 4 parts of oil, 2 parts of water and 1 part of gum. The acacia and the oil are placed in a dry porcelain mortar. In a dry porcelain mortar, when the acacia is thoroughly distributed throughout the oil, as in this case in dry gum method, we dissolve the acacia, the emulsifying agent, in oil. Then after thoroughly distribution, what should be done? Water should be added all at once. The mixture is triturated continuously. The mixture is triturated continuously, but lightly in one direction. Lightly in one direction until the mixture thickness under the pestle. Until the mixture thickens under the pestle, as we have discussed that on small scale, for the preparation of emulsion, we should use the porcelain mortar and pestle. The primary emulsion is triturated for at least 5 minutes. The primary emulsion is triturated for at least 5 minutes. You should keep in your mind that if you are going to prepare emulsion, so in that case the primary emulsion must be triturated for at least 5 minutes. Finally, the emulsion is transferred to a graduated cylinder or suitable container. After the preparation of emulsion, it is transferred to a graduated cylinder or suitable container. The emulsion should be labeled as shake well before use, because it is the mixture of two immiscible liquids which is emulsified by means of emulsifying agents. So similarly, like suspension, for this suspension the label should be like this: shake well before use. So similarly, the same label should be used for the emulsion, like shake well before use. English Arvadaga method. English Arvadaga method, as we can use the term English method for what? For Arvadaga method. In this case, emulsifier like acacia is added to water to form a mucilage. Then oil is slowly added to emulsion. While in case of dry gum method, the acacia or emulsifier or emulsifying agent is added to the oil and then water is added. But in this case, the acacia or emulsifier is added to the water to form a mucilage. Then oil is added to form emulsion. The quantities of oil, water and gum for pre-immersion are calculated like same in dry gum method: 4 parts of oil, 2 parts of water and 1 part of gum. Acacia and water are triturated to form a mucilage in a porcelain mortar. Then the oil is added in small amounts with constant, rapid and light trituration, sometimes rapid and sometimes light trituration. When all the oil has been added, the mixture is triturated vigorously for a few minutes. After the additions of all oil, what should be done? The mixture should be triturated vigorously for a few minutes. Finally, the emulsion is transferred to a graduated cylinder or a suitable container and brought to volume with water, and the final volume must be made with the help of water. It means that we should use or add further water to make the final volume. Bottle or Forbes bottle method. It is extemporaneous preparation for volatile oils or oil with low viscosity. If oil is of low viscosity, or oil is volatile, so what method should be used? Bottle or 4 bottle method should be used in such type of preparation of emulsion. First, mix gum and oil in a beaker. Shake it well for the mixing. Water is added in portions with vigorous stirring and mix it well to make a primary emulsion. Then next, add up remaining quantity of water to make the final volume. Auxiliary method. An emulsion is prepared by wet gum or dry gum method can generally be increased in quantity by passing it through a hand homogenizer. In these apparatus, the pumping action of the handle forces the emulsion through a very small orifice and reducing the dispersed droplet size to about 5 microns or less. Test for emulsion after the preparation of emulsion. So different tests are used for the identification purpose of emulsion. So here are the different tests which are used for the emulsion, for the water oil emulsion or oil water emulsion, like a dilution test, conductivity test, and dye solubility test, refractive index measurement, and filter paper. These are the different tests which are used for the identification of oil water, water oil or oil water emulsion. So the first one, dilution test, based on the stability of external phase of emulsion. As we have discussed in our previous lecture, that there are two phases in emulsion. One is external phase and the other one is internal phase. So based on the stability of external phase of emulsion, oil water emulsion can be diluted with water. Water oil emulsion can be diluted with oil. In these tests, the emulsion is diluted either with oil or water. If the emulsion is oil water type and it is diluted with water, it will remain stable. If we add water into oil water emulsion, so it will remain stable, as water is the dispersion medium. But if it is diluted with oil, the emulsion will break. If instead of water we add oil, then the emulsion will be broke, as oil and water are not miscible with each other. Oil in water emulsion can easily be diluted with an aqueous solvent, whereas water in oil emulsion can be diluted with an oil liquid. Like you can see over here, oil in water emulsion, if we add or we dilute it with water, so no phase change will occur. The same emulsion, the stability of emulsion will not be affected. Oil in water emulsion, as you can see in this figure. But if oil in water emulsion is diluted with oil, then phase change will be occurred. You can see over here, oil in water emulsion, so there is phase change in the if we are going to add oil instead of water, so the emulsion will be destabilized, phase changes will be occurred. Conductivity test. The basic principle of this test is that water is a good conductor of electricity. Therefore, in case of oil water emulsion, this test will be positive, as water is the external phase. In this test, an assembly is used in which a pair of electrodes connected to an electric bulb which is dipped into an emulsion. If the emulsion is of oil water type, the electric bulb glows. Like you can see over here, it is a bulb, it is the beaker, and these are electrodes. If and it is a oil water emulsion. Dye solubility test. In these tests, an emulsion is mixed with a water soluble dye like amaranth and observed under the microscope. If the continuous phase appears red, it means that the emulsion is oil water type, as water is in the external phase and the dye will dissolve in it to give color, because amaranth is water soluble dye. If the scattered globules appear red and continuous phase colorless, then it is water oil type, because as I told you that amaranth is soluble in water. So if the globules which are scattered, if the globules appear red and continuous phase is colorless, then we can detect that it is a water oil type emulsion. Similarly, if an oil soluble dye like scarlet red sea or Sudan 3 is added to an emulsion and the continuous phase appears red, then it is water oil emulsion. Water oil emulsion. Refractive index and filter paper test. Refractive index and filter paper test. Fluorescent test. If an emulsion and exposure to ultraviolet light radiation show continuous fluorescence under microscope, then it is water oil type, and if it shows only spotty fluorescence, then it is oil water type emulsion. Understand? Similarly, cobalt chloride test, which is also used for the identification of emulsion when a filter paper soaked in cobalt chloride solution is dipped into an emulsion and dried, it turns from blue to pink, indicating that the emulsion is oil water type. Oil water type. Types of physical instability. Flocculation, it is instability of emulsion. Creaming or sedimentation, it is also instability, physical instability of emulsion. Aggregation or coalescence, it is also instability of emulsion. Phase inversion, it is also the instability of emulsion. As you can see in this figure, the different types of instability, we can say the physical instability of emulsion, like coalescence, or you can see over here. Similarly, flocculation and creaming and breaking, these are the physical instability of emulsion. So in case of flocculation, you can see neighboring globules come closer to each other and form colonies in the continuous phase. This aggregation of globules is not clearly visible. Not clearly visible. This is the initial stage that leads to instability. Instability of what? Instability of emulsion. Flocculation of the dispersed phase may take place before, during, or after creaming. Understand? Flocculation of the dispersed phase may take place before, during, or after creaming. The reversibility of flocculation depends upon strength of interaction between particles as determined by the chemical nature of emulsifier. First one, the chemical nature of emulsifier or emulsifying agents. Similarly, the phase volume ratio, the concentration of dissolved substances, especially electrolytes and ionic emulsifiers. The extent of flocculation of globules depends on globule size distribution, charge on the globule surface, viscosity of the external medium, globule size distribution. Uniform size globules prevent fluctuation. If the size of globule is same, uniform, then there will be no fluctuation. If we want to prevent the fluctuation, so the globule size must be uniform. This can be achieved by proper size reduction process. Proper size reduction process. The other one is charge on the globule surface. That is, a charge on the globule exert repulsive forces with the neighboring globules. This can be achieved by using ionic emulsifying agent, electrolytes, etc. Charge on the globule size. This can be achieved by using emulsifying agent, electrolytes, etc. Viscosity of the external medium. Viscosity of the external medium. If the viscosity of the external medium is increased, the globules become relatively immobile and fluctuation can be prevented. So how can we prevent the fluctuation? If we want to prevent the fluctuation in immersion, because fluctuation is a physical instability, so we can increase the viscosity of external medium. If viscosity of the external medium is increased, that what will be happened? The globules become relatively immobile. If globules are immobile, so there are less chances of fluctuations. So we can prevent the fluctuation process if we enhance or increase the viscosity of external medium. This can be obtained by adding viscosity improving agents, bonding agents or thickening agents such as hydrocolloids or waxes. Flocks slowly move either upward or downward, leading to creaming. Fluctuation is due to the interaction of attractive and repulsive forces, whereas creaming is due to density differences in the toe phases. Creaming is the upward movement of dispersed droplets or globules of emulsion relative to the continuous phase due to the density difference between toe phases. If there is difference in the density between toe phases, then there are chances of the dispersed globules to move upward. And creaming is the concentration of globules at the top or bottom of the emulsion. Creaming is the concentration of globules at the top or bottom of the emulsion. If there is difference in the density of two phases, so there will be chances of creaming. So the creamings may be upward or it may be downward. Droplet larger than 1 millimeter may settle preferentially to the top are the bottom under gravitational forces. Under gravitational forces, creaming may also be absorbed on account of the difference of individual globules movement rather than flux. It can be absorbed by difference in color shade of the layers. It is reversible process. For example, the cream can be redispersed easily by agitation. This is possible because the oil globules are still surrounded by the protective sheath of the emulsifier. Protective sheath of the emulsifier. Creaming results in lack of uniformity of drug distribution. This leads to variable dosage. Therefore, the emulsion should be shaken thoroughly before use. Why we use the label? For the label that the emulsion should be shaken thoroughly before use, as in label we mostly write on the container of the emulsion the label shake well before use. Creaming is of two types: upward creaming and downward creaming. Upward creaming is due to the dispersed phase is less dense than the continuous phase. This is normally absorbed in oil water emulsion. Upward creaming is mostly absorbed in oil water emulsion. The velocity of sedimentation becomes negative. Downward creaming occurs if the dispersed phase is heavier than the continuous phase. Due to gravitational pull, the globules settle down. This is normally observed in water oil emulsion. Downward creaming mostly absorbed in water oil emulsions. Water oil emulsion. Since creaming involves the movement of globules in emulsion, Stokes' law can be applied. Creaming is influenced by globule size, viscosity of the dispersion medium, difference in the densities of dispersed phase and dispersion medium. Creaming can be reduced or prevented by reducing the particle size by homogenization, doubling the diameter of oil. Globules increase the creaming rate by a factor of 4, increasing the viscosity of the external phase by adding the thickening agents such as methyl cellulose, tragacanth, or sodium alginate. Methyl cellulose, tragacanth, or sodium alginate. Similarly, reducing the difference in the densities between the dispersed phase and dispersion medium. So these are the different mechanisms by means of which we can reduce the creaming in emulsion. Coalescence, aggregation, coalescence, breaking. Aggregation, dispersed particles come together but don't fuse. In this case, in aggregation, the dispersed particles come together but there is no fusion. Coalescence is the process by which emulsified particles merge with each other to form large particles. This type of close packing induces greater cohesion, which leads to coalescence. In this process, the emulsifier film around the globule is destroyed to a certain extent. These steps can be recognized by increased globule size and reduced number of globules. Coalescence is absorbed due to insufficient amount of the emulsifying agent. Coalescence is absorbed due to insufficient amount of the emulsifying agent. Altered partitioning of the emulsifying agent. Incompatibilities between emulsifying agents. Breaking Breaking is the destroying of the film, surrender the particles. Breaking is also the physical instability of emulsion. Separation of the internal phase from the external phase is called breaking of the emulsion. Separation of the internal phase from the external phase is called breaking of the emulsion. This is indicated by complete separation of oil and aqueous phases. It is an irreversible process. For example, simple mixing fails. It is to resuspend the globules into an uniform emulsion. In breaking, the protective sheath around the globule is completely destroyed and oil tends to coalesce. Phase inversion. This involves the change of emulsion type from oil water to water oil or vice versa. When we intend to prepare one type of emulsion, say oil water, and if the final emulsion turns out to be water oil, it can be termed as a sign of instability. Extemporaneous dispensing of emulsion. Cod liver oil emulsion. It is the example of extemporaneous emulsion. That how can we prepare extemporaneous emulsion? So cod liver oil emulsion is the example of extemporaneous mixture of emulsion. So as you can see in this formula, cod liver oil 100 ml, gum acacia 25 gram, gum tragacanth 15 gram, benzaldehyde spirit 0.5 ml, saccharine 0.02 gram, chloroform 0.5 ml, distilled water sufficient quantity to make the final volume 200 ml. So these are the different ingredients which are used in the preparation of cod liver oil emulsion. If we want to prepare extemporaneously this mixture, this emulsion, so these are the different ingredients which are used in the preparation or in the formulation of cod liver oil emulsion. So how can we prepare such type of emulsion preparation? First of all, mix gum acacia and gum tragacanth with cod liver oil and triturate well to make primary emulsion by dry gum method. So in this case, we mix gum acacia and gum tragacanth with what? With cod liver oil instead of water. So therefore, we use the term dry gum method. It is the dry gum method because in this case, we triturate cod liver oil and mix gum acacia and gum tragacanth, while in wet gum method, we first prepare the mucilage of water and acacia. But in this case, we mix gum acacia and gum tragacanth with cod liver oil and triturate well to make the primary emulsion. Then add small amount of water and mix well. After that, then add benzaldehyde spirit, chloroform and saccharine sodium by stirring, and then add the remaining water to make the final volume up to 200 ml. So it is the simple method for the preparation of cod liver oil emulsion. The dose, how much quantity should be used? 10 ml per day. Daily we can use 10 ml. The label, because it is an emulsion, so on the container it should be written shake well before use. Uses: forward purpose cod liver oil emulsion is used. It is used for vitamin A and D deficiency. If there is deficiency of A and D vitamins, then we can recommend cod liver oil emulsion. Liquid paraffin emulsion. The formula for these emulsion is like you can see the different ingredients, name of different ingredients and their quantities. Liquid paraffin 500 ml, vanillin 0.5 gram, chloroform 2.5 ml, saccharin sodium 0.05 gram, benzoic acid solution 20 ml, methyl cellulose 20 gram, distilled water sufficient quantity to make the final volume up to 1000 ml. Preparation. First of all, mix the methyl cellulose with 200 ml boiling water and then allow to stand for 2 hours with constant stirring. Then dissolve vanillin in a mixture of chloroform and benzoic acid solution with vigorous stirring. Then add saccharin sodium, which is already dissolved in sufficient quantity of distilled water. And after that, add methyl cellulose to this mixture and mix sufficient quantity of distilled water to make the final volume up to 1000 ml. So in this case, the dose 30 ml to be taken at bedtime. Label: shake well before use. Use as a laxative. So it was all about the emulsion, the different methods of emulsion, and the different tests which are used for the identification of emulsion and the physical instability of emulsion. So, and similarly, we discussed all about the extemporaneous dispensing of emulsion, the different extemporaneous mixtures of emulsion like cod liver oil and liquid paraffin emulsion. So thank you so much. God bless you. Inshallah, we will try to discuss in our coming lecture all about the suspension and the extemporaneous dispensing of suspension, or we can say the extemporaneous mixtures of suspension. So thank you so much.